This is a diagram of a wormhole with a time-traveling astronaut in it. Here's what happens if you close one end of the wormhole, trapping the astronaut inside. I'll put the physics in the details later. The point here is that the astronaut can never escape. He or she will be trapped forever. I've mentioned this before, but it bears repeating. If you're an astronaut who finds themselves in this situation, don't panic. It's not the end of the world. You can still have a great life. Just start a blog. I would know, but there's another thing that's even weirder about this diagram. There's nothing in the math that says the astronaut has to stay in the same time that they entered the wormhole. In fact, when we do the math, we find that there's no way for the astronaut to prevent themselves from traveling into the future after falling into a closed wormhole. And that's weird. Let me explain why. Let's say our astronaut friend is a massive narcissist. This person has no interest in helping others. They aren't even interested in saving themselves. This person only cares about one thing, getting more stuff. Our astronaut buddy is carrying a big pile of gold in their spaceship, and that's all they care about. That gold they won't trade for anything. Now, suppose our narcissist astronaut makes it to a distant star system that is 10 light years away from their home. Suppose they arrive at their destination just as the sun sets, which means they have 12 hours before their ship's solar panels stop working. They need to gather enough energy to get back home. But how? Well, lucky for them, the planet they landed on has a whole bunch of oil wells that are just sitting there practically begging to be used. Our astronaut could burn some of that oil and use the energy to power their ship and fly home. But wait, the astronaut isn't really interested in using energy. All they want is gold. Can they find some other way to use that oil to make gold? Oh yeah, look at this diagram. If our astronaut burns the oil and throws the ash out of their airlock, they'll have gold in their hands and enough energy to get home. Wait, hold on, that can't possibly be right. Where did the gold come from? It didn't come from anywhere. It was always there. Yeah, sure, the oil burned into something different, but the gold was already there. The entire time, like it was always going to be. That's because the gold is actually where the energy came from in the first place. It seems that the only way for the astronaut to not get stuck in this dead star system is to throw away the gold they traveled with into the ether. And now the question is, where does the gold go? Well, unfortunately, it goes back in time. In fact, everything the astronaut does goes back in time. Let me explain. So let's say that instead of throwing the gold away, the astronaut decides to hold onto it and travel around the planet. That doesn't work. They need more energy. What if they buy a new spaceship made out of antimatter and annihilate it with their gold? The answer is yes, this works, but not without consequences. When the gold and antimatter annihilate, they make a burst of energy, but that energy goes backwards in time. It's like flipping a movie reel. Instead of the energy coming out of the annihilation making the gold and the ship come out of the energy. Now the question is, where does the energy go? Well, unfortunately, it goes forward in time. So the energy from the annihilation ends up powering the ship that created it. In other words, the energy from the annihilation goes to the future, eventually ending up powering a ship that then travels back in time to create the very energy that powered it in the first place. We call this an advanced action reaction. It's like when you throw a ball straight up in the air and it comes back down. But the difference between that and this is that the ball doesn't go backwards in time. That's why I said earlier that there's nothing in the math that says the astronaut has to stay in the same time that they entered the wormhole. The only thing that keeps the astronaut in their own timeline is the pile of gold they brought with them. That gold constrains the energy in their timeline so that it matches the energy in the universe at large. But if they throw the gold away, then the constraint goes away and the energy from every action they take flows back to them in the form of a time-traveling energy loop. And here's the thing, you can keep on doing stuff, making more energy, and then sending that energy back in time to make more energy, and then sending that energy back in time to make even more energy. You can make an infinite amount of energy this way. You might be thinking that's impossible. How can you make infinite energy? Who allowed that? No one allowed that. The laws of physics didn't allow it either, except that there's one law of physics that the math tells us gets broken in the presence of a wormhole. It's the conservation of energy. You might think energy conservation is unbreakable. You can't break it, can't bend it, can't ignore it. And that's true most of the time, but not in the presence of a wormhole. The presence of a wormhole allows you to break energy conservation by trading energy in the future for energy in the past. And that's weird. Physicists haven't agreed on how to fix this yet. One idea is that the total amount of energy in the universe is conserved, but the distribution of energy in the universe isn't. That means you can have negative energy in one part of the universe as long as you're reusing that negative energy to make positive energy somewhere else. Another idea is that the wormhole itself has a huge amount of energy inside of it, and the two ends of the wormhole act like a battery that drains as energy gets pumped in. One thing we know is that this is a real mathematical possibility. The equations that describe gravity, electromagnetism, and quantum mechanics, if you combine them all together and include a wormhole, tell us that you can make an infinite amount of energy by sending stuff through a wormhole. Physicists don't like that, so one of these days they're probably going to fix it. But in the meantime, we should enjoy having the freedom to break the laws of physics whenever we want. To learn more about the math behind negative energy and wormholes, check out the course on our website. Thanks for watching.